So this is the microbiology required practical. Again, it's triple only. And the whole point of this is to investigate the effect of antiseptics or antibiotics on bacterial growth using agar plates. And the whole thing that you're measuring this is something called the zone of inhibition that is I will go through in the actual practical itself. Now, aseptic techniques, right? You need to know what they are, right? And what I've done here is I've just kind of found a diagram. And the diagram, it goes through the fact that you need a Bunsen burner. Your inoculating loop must be heated up in the Bunsen burner to make sure everything is then killed. So it's got to be at a high temperature. This one shows then that it must cool down. This one then shows that once it's cooled down, right, you've got to make sure that it goes into your bacteria solution, right, as a cooled down one, or else it's going to end up killing the bacteria. Make sure that you are flaming everything, so you flame the bottle to make sure there's no bacteria on the outside of it. When you open the bottle, you put it next to a flame to make sure there's nothing that can get into it. Number 6 is then you inoculate your agar, right, with the bacteria itself, and then what you do is you heat it all up again, and then you sterilize everything again. The final part is your bacteria are then put at 25 degrees because then that is their optimum growing temperature. You can also use ethanol, right, because ethanol will also sterilize things. So what I'll tend to do is to do proper aseptic technique. I'll heat it up in a Bunsen burner and I'll use ethanol, right, to make sure that it is as sterile as possible. Now the practical itself. Thoroughly clean beforehand and after the experiments, right? That's using kind of antibacterial spray. And the best way to do it is going to almost like make yourself a square on the table and make sure that that square is as clean as you can possibly have it. Antibacterial spray, make sure you're washing your hands, make sure there's no way on this planet that any bacteria can then get anywhere near it. Divide the plate into 3 equal sections, right? So you can see the diagram at the bottom here, it's split up into 3. And label them 1, 2 and 3 around the edge. Put a dot in the middle of each section. There's a dot, there's a dot, there's a dot. And then inoculate the loop, inoculate the plate with E. coli and add your initials, date and the name of the bacteria. So there's the initials, there's the date, and there's the name of the bacteria. That is then just to know exactly when the plate was actually made, by who and what bacteria was on it. Wash your hands, right? So you just got to keep on doing aseptic techniques. Wash your hands again. Then put a different antiseptic, or it could be a different antibiotic, into each of the 3 sections, right? So where those dots are, you can then put 3 different antibiotics, or what you could do is you could put an antibiotic there, and then just put a dot there, right? And then that's like a comparison. Carefully lift the lid of the agar plate at an angle away from your face so you're not breathing on it. Use the forceps, put the discs where the dots are, secure the lid of the agar plate, but you don't seal it, because if you seal it, that creates anaerobic conditions and we don't want that. Then put it into an incubator at 25 degrees for 48 hours. Then measure the diameter of the clear zone around each individual disc. So I'll just go through what that means. So what you'll find is, now this has got 4 individual things on it. But what you've got, D there, is an antibiotic or an antiseptic. What you can do is you can see around the outside there's a circle. That circle is called the zone of inhibition, right? It's where the bacteria can't grow. All right, so we just go through your variables. Don't mess in class. So don't mess. What we're measuring the zone of inhibition. What we're changing between each one is the antiseptic or the antibiotic. And what we keep the same is the temperature, 25 degrees for 48 hours, the agar, the type of bacteria. Now to actually calculate the zone of inhibition, what you're going to do is you're going to use a bit of maths. Right, you're going to see a circle around the outside that, and you've got your dot in the middle. You need to work out, do a few radiuses, right, because the circle might not be perfect. Once you've done a few radiuses, you do a mean, and then using the formula, area equals pi r squared, you can then calculate the zone of inhibition of each one of those individual antibiotics. And from that then, you can then compare. So the final part of it is you can then compare the antibiotics or the antiseptics to see which is the biggest. The one with the biggest zone of inhibition is the most effective antiseptic or antibiotic.